All right, so we're starting chapter 13 today. So if you want to get the notes out of OneNote, you can copy them over from the content library. I have a new section in the notes section called chapter 13. I only have lesson 1 in there right now. I'll be uploading lessons 2 and 3 over the weekend, so you'll need to download those going into next week. You probably saw there was a Microsoft Teams assignment that posted this morning. That assignment goes along with this lesson, so you can either listen to this lesson and answer the questions on the assignment, or you can also go to the book and you can find the questions in lesson 1 of chapter 13 of the book, so they all go together. So we're looking at types of mixtures. This one's going to be pretty short because we've already learned a lot of this stuff. All right. This is going to look very similar to what we've done during the school year. Here's some new vocabulary, and you should know all of these terms. So all of these terms will probably show up on your homework assignment that goes with this lesson, but we'll talk about each one of these individually. Just some review vocabulary. The solute is a substance that dissolves in the solution. So if I had like a beaker of water in here, and I were to put a shaker of salt, good shaker of salt, and I have this salt going into the water, it's going to produce what we call salt water. Okay, the salt going in is the solute. The water here is the solvent. So we have the solvent and the solute. Together they make a solution. So it's just something to remember there. All right. We also probably remember there are two types of mixtures, heterogeneous and homogeneous mixtures. What we're going to do in this lesson is we're going to break it down a little further. There are two types of heterogeneous mixtures when we mix stuff together, and one is called a suspension. And this is probably the one type of heterogeneous mixture you're most familiar with, is a suspension. A suspension means the particles in the mixture are so heavy that they start to move downwards, and eventually they all settle out on the bottom of a container. So a heterogeneous mixture like this mixture here can be filtered out. We did this in the lab, and so you end up getting the pure liquid here, and all the particles end up in the filter. Okay, so that's called a suspension. And a suspension only stays a mixture as long as you're mixing it. As soon as you stop mixing, it settles out. Probably the one you're most familiar with is orange juice. That pulp settles out at the bottom. Chocolate milk is another suspension that the chocolate particles settle to the bottom. Another type of heterogeneous mixture is called a colloid. So a colloid, the particles are small enough to stay suspended in the mixture without settling out. And these particles are too big to consider this a solution. Sometimes they can be filtered out, but when they're in there, the random movement of the water molecules, so if I have a water molecule like this, its random motion, these water molecules just moving randomly, make the little tiny colloid particles, or the colloid particles might be almost as big as the water molecules. It just keeps bumping them upwards. It just keeps bumping into them. It's almost like when you've been at a party and somebody's had a balloon in the air and you try to keep popping it up so it doesn't hit the ground, or a beach ball at a concert. That's the same thing the water molecules do to these particles. So these particles aren't so big that they settle out at the bottom. The movement, this random movement, is called Brownian motion. It was named after Robert Brown, who noticed the random movement of pollen grains. So the erratic movement of colloid particles that keeps them from settling out is called Brownian motion. Okay, this is called a dispersed phase, if you will. Mayonnaise is a colloid. but we can tell something is a colloid by shining a beam of light through it. If you shine a beam of light through it, you actually see the beam. You've experienced this in fog with headlights, or rays of the sun, like sun rays coming in through the window, and you can kind of see the beam through the dust particles or even through smoke. If you've ever been camping, a flashlight through a campfire smoke makes these beams. That's the Tyndall effect, is what that is called. So that's referred to as the Tyndall effect. So the Tyndall effect is how we recognize a colloid. Brownian motion is what keeps the particles from settling out. Well, now that we've talked about heterogeneous mixtures, we need to talk about homogeneous mixtures. Homogeneous mixtures are the ones we use in chemistry most often, and there's lots of different examples of them. In your homework, you need to write down a couple examples of different types of solutions. So when you look in there and it asks you to give an example of a certain type of solution, you can use this table to help you with that, but you're familiar with probably almost all of these. And in fact, most things that we deal with in the lab and most things that you deal with in everyday life are actually solutions. Very rarely do we deal with things as a pure thing. Here's a liquid solute and a liquid solution. We have ethanol and water makes a solution. This is actually the composition of most alcoholic drinks. If you have jewelry that's 14 karat gold, that's actually a solid in solid solution. We call that an alloy. And then we also can have pure gold that we wear as jewelry, but most often we're dealing with this alloy as gold that has a small amount of copper and silver in it. Homogeneous mixtures, when we look at them, we say that they can either be soluble or insoluble. Soluble or insoluble. We learned when we did double replacement reactions our solubility rules, and we're not going to revisit those right now, so don't worry. However, if we have two things that we mix together, like here we have lithium, whoa, my guy went crazy here, here we go, lithium chloride and toluene. The lithium chloride separates at the bottom and does not dissolve, so we would say lithium chloride is insoluble in toluene, but lithium chloride in water forms a solution, so we would say it's soluble. If we're referencing two liquids, we use different terms. Two liquids that mix readily are said to be miscible. So alcohol and water, vinegar and water are miscible. Oil and vinegar, oil and water are immiscible. Toluene and water, that's just toluene's a very common organic compound. It forms this separate layer, and you can see a second layer. You have the toluene on top, and then you have the water on the bottom, and it's separated by that little meniscus there, and we would say that those two substances are immiscible. So two liquids that do not mix are said to be immiscible. And then here's just a little data table to show you different types. You have homogeneous mixtures that we call solutions, and here's some of their properties here. And then we have heterogeneous mixtures that are broken down into two different categories. You have suspensions and colloids, and I even put this in here, and you can kind of see the different size of the particles. Remember, your Tyndall effect is that seeing the beam of light through the substance, all right? And then suspensions will separate out, and you can filter them out. As long as you don't agitate them, they'll separate out. If you continue to agitate them, they'll stay mixed up. So there's a short lesson today. Hopefully you were able to answer all the questions on the worksheet. When you get done, submit that form. Make sure to press turn in on the Teams assignment, and you have the rest of the day to get that done. That guy's technically due on Saturday, but I have a feeling you're probably already done with it. I hope you guys have a great rest of your week and a good weekend.